Alright, this is continuing your Unit 10 review. We'll start with problem 10 in this video. The 1 through 9 were in the previous videos. So it says, put this in proper rational form, give domain, identify all asymptotes, horizontal, vertical, and slant. So here it is, looking at this. As far as a horizontal goes, it's bigger on top, so there's no horizontal. And that's going off of our list and this acronym, which we use throughout this unit. So this one was bigger on top, so no horizontal. Vertical asymptote, well, that comes from factors in the denominator that do not cancel, and x squared plus 9 will not factor. So that means no factors in the denominator means no vertical asymptotes, and there would be no holes either. The domain, because nothing would be excluded from the domain because there are no factors in the denominator that we would need to set equal to 0 and identify those values of the domain that would need to be excluded. That means that it's all real numbers. For domain, there's nothing excluded because there are no factors in the denominator. Slant asymptote, that's going to come from putting this in proper rational form. Proper rational form says the degree of the numerator has to be less than the degree of the denominator, and in this case we have degree 3 on top in the numerator, degree 2 in the denominator, so it's not in proper rational form. So we'll do long division on that. It is 1 degree bigger on top than bottom, so we will have a slant, and we'll get that as we do this long division. So x squared plus 9, so I would need an x here to give me an x cubed there, x times 9 plus 9x. So that would cancel. This flips to subtraction. 2x minus 9x, negative 7x. Nothing left to bring down, so that means this is my remainder. So that would be minus 7x over x squared plus 9. So the equation of the slant is that y equals everything in front of the remainder. So the slant would be y equals x, and that answers that question completely. Okay, in problem 11, we are asked to sketch the graph of the given function, labeling all intercepts and asymptotes. So we'll do that. I've gone ahead and written it so that we have the horizontal division bar there instead of the slash like they start with, and then I've gone ahead and fully factored it. So horizontal asymptotes, looking at our list, that's the Bobo, Bot, and HTC, bigger on bottom, bigger on top, or are the exponents the same? This one is bigger on bottom, so that means that the horizontal asymptote is y equals 0. So that's coming again from our list right here. Bigger on bottom, y equals 0 for horizontal asymptote. Slant asymptote, we have a horizontal, so we don't have a slant. Vertical asymptotes come from factors in the denominator that do not cancel, so that would be this factor right here. So we have a vertical asymptote at x equals 2 coming from that factor. Holes come from factors that cancel between numerator and denominator, so that would be that one there. So there's a hole at 3 comma, and we'll get the y value in just a moment. Roots come from factors in the numerator that didn't cancel. There are none, so no roots. This will not cross the x-axis. And then the y-intercept occurs when x is 0, so we evaluate the function when x is 0, so f of 0 equals, and basically we can cover up all the x terms and evaluate what's left. So we have negative 12 over 6 left after you cancel out or cross out all of the terms with an x in them. If x is 0, those terms go to 0. So negative 12 over 6 becomes negative 2. So the y-intercept is 0, negative 2. Now we need to find the y value of the hole in the graph, so we evaluate what's left. That's these two parts after we've canceled the factor that cancels that gives us the hole. So we're left with 4 over x minus 2, and we evaluate that at an x value of 3 because that's where the hole is. So that would be 4 over 3 minus 2, which is 4 over 1, which is 4. So there's a hole in the graph at 3, 4. So that should be enough to now sketch the graph. If not, we'll use a test point. So we have a vertical asymptote, x equals 2, right through here. And we have a horizontal asymptote at y equals 0, right through there. And then we have a hole in the graph at 3, 4. And we have a y-intercept of 0, negative 2 down here. So, based on that information, we have to approach the horizontal asymptote as x goes to negative infinity over here, and then we have to go through that y-intercept, and then we have to approach the vertical asymptote as y goes to negative infinity there. And over here, we have to approach this vertical asymptote as y is going to positive infinity there, go past that hole in the graph, and then approach the horizontal asymptote at the far right side of the graph as x goes to positive infinity. So that's the way that graph has to look. We'll label the hole in the graph there, we'll label the y-intercept there at -2, and that's it for problem 11. All right, on problem 12, same as problem 11. So on 11 through 15, we're asked to sketch the graph of the given function, labeling all intercepts and asymptotes. So I've gone ahead and rewritten the function. It is fully factored because x squared plus 3 will not factor anymore. So we look at this section of our list, Bobo, Bot, and HDC, and this one happens to be bigger on bottom, so it's y equals 0 for the horizontal. We have degree 2 on bottom, degree 1 on top, so bigger on bottom. That's y equals 0 for the horizontal asymptote. Vertical asymptote, looking at our list, come from factors in the denominator that do not cancel. We've discussed that the denominator no vertical asymptotes. That's going to be the same case for holes, because holes come from factors that cancel between the numerator and denominator. So no factors in the denominators, therefore vertical asymptotes and holes, there are none of those. Roots come from factors in the numerator that don't cancel. Well, there is one factor, this x, 2 times x. So we set 2x equal to 0 and solve, and we get x equals 0. So root is at 0, x equals 0. Y-intercept, we set x to 0, so we cover up the x terms and evaluate what is left. 2 times, I need to cover this whole thing up. So we have 0 on top and 3 on bottom, so f of 0 equals 0 over 3. 0 over 3 is 0, so the y-intercept is 0 as well. So the root and the y-intercept are the same in this case. And slants occur when the numerator is 1 bigger than the denominator in terms of degree. That's not the case here, so no slants. We had a horizontal up here, so that was our other clue that we didn't have a slant. So we'll sketch what we have so far and make any test points that we need. So we know that we have a root here at 0, which is also the y-intercept, and we know that we have a horizontal asymptote on top of the x-axis at y equals 0. So we know we need to approach it, this horizontal asymptote, far right and far left. We know that much, and we know we need to cross through here. We either cross this way or this way, we're not sure which. So we will run a test point and see what comes from that. So I'm going to run a test point at 1 and at -1 so that we can get an idea of what the rest of the graph looks like. So f of 1 would be equal to 2 times 1 over 1 squared plus 3. So that would be 2 over 4, which equals 1/2. So 1 comma 1/2 right there would be a point. And now we'll run another test point on the other side of the y-axis. So f of -1 would be 2 times -1 over -1 all squared plus 3. So that would be -2 over 4, -1/2. Running out of room here. -1/2. So that would be down here. I'm going to erase this part, get it out of our way. So based on that information, I'm going to be below, I'm going to come through here like this, and I have to approach the horizontal asymptote over here, and then I've got to approach it from the bottom on the left side and from the top on the right side. So it has to look like that. And that's it for number 12.